In this video, we're going to go over how to solve systems of linear equations by doing elimination, but we're going to have to alter two equations. So both equations will have to multiply by a number. So if you've yet to watch how to use elimination, I would watch the earlier videos on this first before diving into this one. But if you have watched them and you understand it, let's rock and roll together. So it says solve using elimination. Now, even if you're not told to use elimination and just to solve this system of linear equations, notice that with the r variables, you have different coefficients. 2 and 5 are different, and 3 and -2 are different. And so that means with the t's and the r's, we can't just add or subtract to eliminate. Not only that, there's nothing I can multiply 2 by, no nice number, to get 5 and vice versa. And there's no nice value, no integer I can multiply 3 by to get 2. Or vice versa. So I look at this and I think, if I were to multiply the top equation by 5 and the bottom equation by 2, that would give me 10 and 10. That could eliminate. Or if I multiply 3 by 2 and -2 by 3, that would give me 6's. And those numbers are both smaller than 2 and 5. So I'm going to go with the smaller numbers I have to multiply by. Let's rock and roll. So I'm going to multiply the top equation by 2. That's going to get the 3 to be a 6, and the bottom equation by 3. And that will get this -2 to become a 6. Let's see what happens. So from here I get 4r, remember multiplying everything by 2 so the equation stays true. 2 times 3 is 6t, and then 2 times -5 is -10. Sweet. And then from here I've got 3 times 5, which is 15r. 3 times -2 is -6t, and then 3 times 16 is 48. Awesome. So we know that we're in good shape because one of our two pairs of variables now has the same exact numbers next to them. The coefficients are both 6. So what I'm going to do now to eliminate is I will add, because 6 plus a -6 will give us 0, and that's what we want to do, is eliminate those t values. So again, make sure that you write out that sign right there, that plus, to show you're adding. 4r plus 15r is 19r, sweet. 6t plus a -6t is 0, so they cancel, and that's what you wanted to have happen. 10 plus, -10 plus 48 is a positive 38. Now, here's my advice. I would get to this step on 5 to 10 problems in a row, where you're practicing figuring out what to multiply by and whether to add or subtract the two equations and successfully eliminating one of the two variables. And then stopping and then going to the next problem and doing the same thing. The reason why I would do that is because now you're practicing the new part of this process, the elimination part. So just take my advice on there. Now, from here, I'm going to continue solving out the problem, but I would practice it the way that I just suggested. So I'm going to divide both sides by 19 because I want to get r alone. And that leaves us with r equals 2. Now from here, we're not done. We need to solve for both variables. When r is equal to 2, we'll figure out what t is. Now, as I've reminded in earlier videos, I'll remind you again, you always want to evaluate or plug in the numbers you get back into original equations. Just in case you made an error in multiplying by 2 or by 3, we won't pick up that error if we plug in the value into where the error has already happened. So I plug 2 into, let's pick this equation. They're smaller numbers. So I have 2r, using this top equation here, would be 2 times 2, that's the r value, plus 3t is equal to -5. And all I have left to do is solve. 2 times 2 is 4, plus 3t is equal to -5. I'm going to subtract 4 from both sides, just solving a normal old equation. So I subtract 4, and so now, here, I'll get a little more room here, I get 3t is equal to -5 minus 4 is -9. And divide by 3 on both sides, and we've got our answer. T is equal to -3. So you have your solution, r is 2, t is -3. And of course, you can check your answer. We could check our answer by plugging our values into this equation. So I'll do a check right here. So I have 5 times 2 minus 2 times -3. And the question is, does it equal to 16? And I'm using that bottom equation because we just used the top equation to evaluate for t. 5 times 2 is 10. -2 times -3 is positive 6. 10 and positive 6, it's 16. We're right. All right, on to the next one. Let's check it out. So in this equation right here, we are going to eliminate again. And to eliminate, we need to figure out that, well, the 3 and the 4, there's nothing we can multiply by, no nice integer that will get these two numbers to be the same. Same with 2 and 3. So you can eliminate either the x's or the y's. So in this case, just for giggles, I'm going to eliminate the x's. You could eliminate the y's. It doesn't matter which way you go. So 3 and 4 are going to cancel out if they're both equal to 12. Basically what I'm doing is I'm finding the least common multiple of the two of them, if you want to get fancy. And if I multiply 4 by 3 and 3 by 4, I'll get 12. So what we have left here now is 12x plus 8y is equal to 4. What I did there is I multiplied every single term by 4. Here I'll multiply everything by 3, remembering we have to multiply everything by 3 to keep the equation true. 3 times 3y is 9y. 3 times negative 2 is negative 6. Ah, sweet! So now we have these two values the same, but we have to think, how do I eliminate them? Well, they're both positive, so I would have to subtract one from the other, or add a negative. But remember, we're subtracting everything in that lower equation from the upper equation. 12x minus 12x is 0. 8y minus 9y is minus y. 4 minus a negative 6 is positive 10. So now from here, we've got minus y equals positive 10. So I'm going to divide both sides by negative 1 to get the y alone. And y equals negative 10. Sweet! So we've got one value, but we need a second value, the x value. Again, we're going to plug y into either of the equations. I'll plug it into the upper equation, but the original one. Always the original one. 3x plus 2 times negative 10 is equal to 1. Just plugging it into that top equation right there, the y value that we got. So I get 3x plus negative 20 is equal to 1. And I guess plus negative 20 you could look at, I'll erase that, as minus 20. And then we're just solving like we would solve a normal equation. I'm going to add 20 to both sides, so I'll do that up here. So add 20. And that gives me 3x equals 21. Divide both sides by 3, solving like normal. And x is equal to 7. And again, we could take these values, 7 and negative 10, and plug them into the other equation that we did not just use, which would be the lower equation. 4 times 7 is 28. 3 times negative 10 is negative 30. 28 and negative 30 is negative 2. So it checks out. Point being here, peeps, if you really want to get good at this and you're struggling with the newer part, the elimination part, just practice multiplying the equations and getting to the elimination step. When you've successfully eliminated, that means you end up with one variable, and from there, the rest of it can be practiced again and again as well. But I think there's enough here to practice without having to worry about all this that you should just practice that part first, and you get really strong at elimination. That's it, peeps.